Welcome to our MathLinks webinar, Dig into Intervention, Fraction Subtraction. As we all know, many students in middle school and beyond struggle with fractions. In this session, we are going to explore some fresh approaches that will make the reteaching of fraction subtraction a positive experience for all. I'm Shelley Kriegler, one of the authors of MathLinks, and our presenter is another MathLinks author, Mark Goldstein. Take it away, Mark.
Thanks, Shelley. Let's get started. Today we're going to look at subtracting fractions with a few visual models and also some mental and procedural strategies for computing. Anyone who teaches mathematics knows that many learners struggle with fractions. Since we're reviewing fractions post-elementary school, we pose the material in a more mature way than students might see in elementary school. We feel compelled to use sense-making strategies for conceptual understanding, as research suggests. Remember that struggling learners often have a hard time memorizing procedures. Understanding concepts helps students remember procedures or retrieve them if forgotten. And we like to help focus students on recording techniques that are similar to the way they will be expected to record their work in algebra. When you begin working on fraction operations, make sure students have some of the prerequisite skills down. In a previous webinar, we used the fraction array for ordering and comparing fractions. Students really have to understand equivalent fractions, or creating fractions with common denominators won't make sense. We like to use the big one, as shown here. As we move forward, you'll see diagrams, mental math when appropriate, and of course, pencil and paper calculations. We'll look at 4 fraction subtraction examples that are sequenced in a developmentally appropriate way. Please view our webinar for adding fractions that could be integrated in with these problems to help round out a more complete addition and subtraction sequence. Let's get started on our first example, subtracting fractions with unlike denominators. Previous experience with fractions, like working with the fraction array, might help students realize that sixths are required. For this area model, the picture shows 2/3, and it can be changed to 4/6. This next picture is also 4/6, but this configuration might make it easier to target the 1/2 or 3/6 that will be removed. However, reconfiguring the picture like this is not required. You might want to give this problem to students to see what they'll do with it. Let's finish off the arithmetic to connect the procedures back to the pictures using the big one. Let's do the same exercise with a linear model. This fraction strip acts like a ruler or a number line. First, we draw an arrow to represent the 2/3 point, and note that it's equivalent to 4/6. And then we represent 1/2 similarly, and note that it's equivalent to 3/6. So on our 6th strip, we can go to the 4/6 point and then back 3/6, which gives us a result of 1/6. And here again is the connection to the procedure. 1 minus a proper fraction. Sure, we could do this procedurally, but give mental math a shot. Anyone who understands basic fraction concepts will probably find the following strategy more efficient. To help students make sense of it, we'll first use a diagram. This area model shows 1 whole with 3/8 removed. Clearly, the other 5/8 remains. This is the procedure, but my personal preference is to avoid writing it all out. See what works best for your students. Here's the same process with a linear model. Again, if students have the basic understanding that a whole is 2/2, 3/3, 4/4, etc., then it's not too tough to know how much is left when a fraction is subtracted from a whole. 3 of the 8ths are removed, so 5 of the 8ths remain. Let's wrap this up a little. Here's a whole number greater than 1 minus a fraction, which is an extension of what we just did. We know 1 minus 3/8 is 5/8, and so what's left is 2 and 5/8. Here's sort of a non-traditional way of recording the process. It explains our thinking because of the 3 holes, we aren't concerned about doing anything to 2 of them, just the one where we remove the 3/8. But all of this work isn't necessary. Here's the same process with a linear model. If you're starting at 3 and subtracting 3/8, the 5/8 must remain in addition to the 2 holes. Here's our final problem, the most difficult one that uses much of what we've seen before. Start with the 3 1/3 sandwiches shown here. Here we're giving away 2.5. Follow along with this recording. It might seem odd, but when connected to the picture, we think it's a very natural process. Remember, 3 1/3 means we're starting with 3 and another third. Giving away 2.5 is giving away 2 and giving away another half. You might have noticed that this is an application of the distributive property. Look back at that picture. From the 3 sandwiches, we first crossed off 2. Then we crossed off a half. That left us with 1/2 and 1/3. So 3 minus 2 is 1 whole sandwich. We still need to take away a half. And we still have that last 1/3. So here's a whole number minus a fraction plus another fraction. And so 5/6 of a sandwich remains. We let the picture drive the procedure. A complicated subtraction problem that traditionally requires regrouping became a simpler addition problem. And if you're a fan of using improper fractions, go for it. Change the mixed numbers to improper fractions. You can see thirds and halves right there. Remove 5 halves. See the 5/6 in the picture that are still left? Procedurally, we would follow a computation using common denominators to arrive at 5/6. Here are the subtraction problems we just did and where they might fit in a sequence that also includes addition. Remember to check out our addition webinar referenced before. Problem 2, add and subtract with unlike denominators using pictures and procedures. Remember that the big one is helpful here when changing fractions to common denominators. And note that you might want to start with denominators where one is a multiple of the other, like halves and fourths, before moving on to one where they're relatively prime, like the thirds and halves you see here. Problem 5, use pictures and then mental math to subtract a proper fraction from a whole. Number 6, extend the above to subtract a proper fraction from a whole greater than 1. And problem number 8, subtract mixed numbers with pictures and then procedures.
Thank you, Mark. That was great. The Center for Mathematics and Teaching is the home for all MathLinks programs. These include comprehensive curriculum for grades 6 through 8, customized intervention programs, and professional development. For more information about our programs, please visit our website at www.mathandteaching.org. We hope you found this session to be valuable. Please feel free to contact us anytime. Thanks for joining us, and see you again next time.